Hey academic stars around the world, welcome back to Caltex Academy. Today on our board, we still have our series of complex numbers, and today I'm going to teach you multiplication of complex numbers. So without wasting time, let's straight go to our first examples. So when you have something like that, you can multiply directly or you can use distributive law. Now let me use two different colors to introduce us on how this distributive law works. So the second color would be this one here, and we have 4 plus 2i. Our first real number here, that is 6, will multiply the second bracket, and that is 4 plus 2i. And the second number, which is the complex part here, that is plus 8i, will also have to multiply the second bracket. And we have 4 plus 2i. Now after that, we can go ahead and distribute through multiplication, and 6 times 4, we get 24. Now we also multiply the second one, 6 times 2i, we get plus 12i. Now we move to the next one here, 8i times 4, we get 32i, so we say plus 32i. Now we're going to multiply the last one here, 8i times positive 2i, we're going to get 16, and this 16 is having I, the I is squared, because I times I is I squared. Now what happened is we have to simplify these numbers in the middle here because they have I and I. Remember, this one is quite different because it is I squared. So we copy our first number here, and we have the number in the middle as 44. So we have plus 44i. Now, in our next number here, we have 16. And remember, somewhere we learned earlier on that if you are given I square, this is equivalent to -1. So if that is the case, we're going to replace our I square here by -1. So let's multiply again. That negative times the positive to bring for us a negative. So here we'll have 24 minus 16, because positive times negative is negative, and we have there 16. And our imaginary part here is already simplified, so we simply copy it down. We have our 44i. So we're just simplifying our number here. Therefore, this simplifies to 8 plus 44i. And that is the answer for the first complex number here. I hope everything is well, and if it is, let's move on to our second example. Yep, in this example, we're given if z1 is equals to 2 plus 3i, and z2 is equals to 3 minus I, and z3 is equals to -2 minus 7i. Evaluate the first part, z1 times z2, second one, z2 times z3, and lastly, z1 times z3. So how do we tackle this out? The same way. And let's start with the first one. This time we're going to use one color. So z1 and z2 is equivalent of, we can replace our z1 by 2 plus 3i, and z2 by 3 minus I. So we can distribute. By the way, you can also multiply directly from here if you don't want to distribute. So let's make it once more, distribution law, and we shall go ahead with the other numbers, just multiplying directly. So we'll have 2 multiplies the second bracket, and that is 3 minus I. And the second number in the first bracket is 3I times the second bracket, 3 minus I. So when we go ahead and multiply these numbers, we have 6 minus 2I plus 9I, and positive times negative is negative. 3 times 1 is 3. I times I is I square. So simplifying the terms in the middle, we have 6. This simplifies to positive 7I, and we know that our I square is negative 1. So let's get more space, and we have the first number remains 6, and the second one also remains 7I. So this simplifies to 3, because negative and negative goes to positive, and we have our 3 times 1 is 3. So we can combine these real parts together. Maybe let me connect them together, and we have 3 plus 6 plus 7I, making 9. So when we have Z1 times Z2, the result will just be 9 plus 7I. I think this is straightforward, and it's a little bit longer. Now let's look at the second option, where we just simply multiply directly. So in part B, we have Z2 times Z3. Now I can switch colors, and let's have our part B here as Z2 times Z3. This is equivalent to our Z2 would be filled in here and Z3 here. So let's take a look at them once more. Z2 is 3 minus I, and Z3 is negative 2 minus 7I. So we can go on, and this time we're multiplying directly. So you can multiply the first number, 3 times negative 2, we get negative 6. Then 3 times negative 7, we get negative 21I. So we move to the second number, we multiply negative I times negative 2. The negative goes to positive, and we have 2I. Then lastly, negative and negative goes to positive again. I times 7I, we get 7I squared. Simplifying the terms in the middle, we get negative 6 minus 19I, and this last term is 7 multiplies negative 1. So here we can even collect it to this side, and we have our negative 6 minus 7. Since 7 times 1 is 7, and positive times negative is negative. So minus our 19I. Now simplifying this together, the signs are the same. We simply add and maintain the sign. So we have here 13 as the real part and 19I as the imaginary part. So if you multiply Z2 and Z3, this is the result we get. Now let's move to the last part of the question, and that is part C. Part C of the question is asking us to get Z1 times Z3, and we know Z1 is 2 plus 3I. So we have here C, Z1 times Z3 is given by 2 plus 3I times Z3, and our Z3 is negative 2 minus 7I. So minus 2 minus 7I. Again, we can go ahead and expand it. Feel free to pause the video and work it on your own if you're already okay, or we follow along together. And here also, we can use distributive law, or we can multiply directly. So let's multiply directly. So 2 times negative 2, we get negative 4. Then 2 times negative 7, we get negative 14I. and we move to the number in the middle, and that is 3i times -2. We get -6i, and we move to the numbers in the end. So positive 3i times -7i, we get -21i squared. Simplifying the terms in the middle, we have our -4 as the first number here, a real number. So this is negative and negative. We add them all up and we get 20, maintaining the sign to be negative, and our I here. So we have -21, and we know I squared is -1. So collecting the real parts together, we have our -4. This time it goes to positive because negative times negative is positive, and we have 21, and we have -20i. And finally, we have to simplify this. Remember, we remove -4 away from 21, and we simply obtain 17 positive. So we have 17 minus 20i. So if we multiply those two complex numbers, Z1 and Z3, the result is what I've just gotten here. Thank you for watching up to this time. If you have gotten some value from this video, go ahead and subscribe to the channel, like the video, and share with friends. See you in the next video where we shall be discussing about complex conjugate. Peace out.